Hey boys and girls, welcome back here to XtremeIE. We're going to talk about creating a RIP instance inside of a VRF. And I want to just quickly talk about some of the reasons why you might do this. The very first reason when we talk about RNS, or when we deal with routing and switching, is of course MPLS Layer 3 VPN. When we talk about Layer 3 VPN, we have to remember that we have a specific order of how things are going to go. So we have R1 here. Let's just say that this guy might be our customer, which would make him our customer edge router. Maybe we are receiving routes into what we would call the provider edge router, and R2 would be our provider. Well, R2 as the provider has to ensure a number of things. It has to ensure that our routes are secured. In other words, it has to ensure that it receives them with no problem. And it has to, when I say secured, it has to ensure that those routes aren't distributed between other customers. So, this customer here, these guys are not allowed to see my routes. And the same thing goes for us to them, right? You don't want to be seeing your customers' routes. Another thing that the provider has to do is ensure that there's no IP conflicts, right? Because what if you guys are all on, the same subnet space, 10.1.1.0/24, something like that, The customer has to make sure that you guys aren't going to break each other's networks or come back to you and say, hey, by the way, you have to subnet 3,000, you have to re-subnet 3,000 devices because there's another customer using the same address space. That doesn't fly ever, right? So using a VRF and Layer 3 VPN, the customer can successfully divide up the routing tables, divide up your routes. He doesn't care what subnet you're on, and he can successfully deliver that traffic over to, the particular router and customer that you essentially want to go to. So that's one application where we need to understand how to do this in a VRF, because what if our customer here is using good old RIP version 2? We have to be able to receive those RIP version 2 routes under that interface now applied in a VRF. And if you have no idea how to actually get RIP to run in a VRF, well, then that doesn't really work, right? You're not going to be successful. Another reason why you're going to use VRFs is security, right? Maybe you want to add different departments. Maybe you have IT, you have management, you have finance. Finance is a big one in some companies. Some companies out there put finance in their own VRF because nobody else in the network is allowed to see anything finance. Finance is like their own company sometimes. Maybe you have multiple different organizations. Maybe you've acquired different companies, and you yourself, you're acting as the service provider, and you don't want this company here that you've acquired over the years to see the routes from this company. So you put them in their own VRF. Well, if this guy's running RIP because he never got around to upgrading, you need to know how to put that in its own VRF. So let's get started. Let me just quickly do some housekeeping here and show you how the network is set up. So what we're going to do is we're going to run a RIP adjacency. We're going to run RIP version 2 between R6 and R4. We're going to redistribute all of our loopback interfaces into the global process of RIP. Then what we're going to do over on R2 is we're going to run a RIP version 2 process, but this guy here is going to be in a VRF. This interface here will be inside of a VRF. So essentially on router 4, we're going to have only one RIP process, and that RIP process is going to handle both for us. It's going to do the global process between 4 and 6, and then it's going to handle these routes coming in between 2 and 4. So let's get that cranking. So I'm going to say show run section RIP, and good old iOS bugs, do show run section RIP. There we go. So there's my global process already running between 6 and 4. You can see here that, let's say do show run section RIP. You can see my typos already. It's late, man. You're all like, oh, let me watch the presidential debate. And I'm like, let me mess around with RIP because that's boring. So here's my RIP configuration here. Very, very simple, no big deal. If I say do show IP route RIP over on router 4, I have my loopback addresses here coming in from router 6, so that's perfect. And let's go ahead and let's get the VRF configured. So I'm going to say IP VRF, and I'm going to call this guy R2. Now, some of you might be wondering, how come you're using IP VRF? Well, in this case, I'm only dealing with IPv4. There's no harm in using the legacy mode of creating a VRF. It makes sure that you guys know how to do it, and it also prepares for RIPNG later on to be able to show you guys how we can upgrade this legacy VRF that may have been created in the past to be able to use IPv6. So don't worry, I'm a step ahead. I'm doing it on purpose. Now, generally speaking, I will always give my VRF a route distinguisher, regardless whether it is needed or not. Doesn't matter what I'm creating it for. I always religiously give this guy a route distinguisher. Now, if I hit the question mark here, you can see that typically the standard is one of these two methods. So you can use the autonomous system followed by a number, a numerical value that you assign it or your service provider gives you. Or you can use the IP address, maybe of the interface, possibly the subnet followed by a number. Believe it or not, if I'm using a routing protocol that has an autonomous system number, I will actually Frankenstein the two of these. The first number will be the IP subnet, and the second one will be the autonomous system. Since I'm not running an autonomous system, here what I'm going to use is the router ID numbers. So I'm going to say 10.2.4.4, that's the interface IP, and then I'm going to use 24 for the router IDs. So do show run section VRF. Here's my route distinguisher that I will typically create, and it tells me, you know, it's in between router 2 and 4. Lower router is always first, and it gives me the actual interface that I should be looking for. Sometimes I'll just do the subnet. Interchangeable. All right. So those are interchangeable for me, I should say. So let's say do show run interface E01, and what we're going to do is we're going to pop that VRF over on this guy. So let's go into that interface. We're going to say IP VRF forwarding, and if I hit the question mark here, the CLI is nice enough to give me that VRF name, and here is exactly why I pull up the interface first. You guys need to learn those tips and tricks through experience. Whenever you apply an IPv4 VRF or whenever you apply a VRF period onto an interface, it's going to strip the address. So what we want to do is we want to religiously make sure that we bring up the interface so that as we apply some of these technologies like VRFs and IPv4, it's going to strip off that IPv4 address. So we have to make sure that we can go back and grab it. So there we go. Do show run interface E01. And the reason why we do this is if I say do show IP route and I say connected, you can see that this route, that interface, is no longer in my global routing table as a connected route. So here's my loopback 0. Here's the interface between router 4 and router 6. Here's the interface or the subnet between router 4 and the switch up here. But this subnet here is nowhere to be found. And the reason is because now it's inside this VRF. So the reason why we're peeling this address off when we apply the VRF is because we're removing that connected subnet from our global routing table and we're putting it in the VRF. And unfortunately, the only way to do that is to reapply the address. So now let's say do show run section RIP again. And one area that may be concerning is the fact that we have a network statement here that already applies to the 10/8 subnet. So you might be thinking, well, we have a 10 subnet here and we have a 10 subnet here. What are we going to do with that? I mean, right now, RIP is already enabled on this interface Ethernet 00, and then we're going to go ahead and we're going to enable it here as well. How is that going to work? Don't worry about it. RIP already has it figured out. So what we're going to do is go into router RIP, and here's where some guys get confused. They're like, wait, there's nothing here. Let me actually exit out of this for a second. Router RIP, and they say, well, there's no VRF instance. What we have to do in order to apply the RIP configuration in a VRF is go into the IPv4 address family. Once we do that, we will see the VRF option. And what we need to do is we need to give it the VRF. And you need to manually type it here because the CLI is not nice enough to actually give you the list of VRFs that you have. So once we do this, we are going to enter a subcontext of RIP where we're underneath almost like a separate routing process where we now have a duplication of all the global routing commands that we normally would have had. So default information, distance, distribute lists, maximum paths, neighbors, networks, offset lists, everything that we would normally do in the global process of RIP, do show run section RIP. All the things we would normally do here, we now have in a separate subcontext underneath this VRF. So in reality, I can almost copy and paste these exact commands. And you can see what RIP does. RIP now is going to say, okay, I'm going to run version 2 in the global process. I'm going to go ahead and advertise or enable the process on any interface that has the 10.0.0.0 subnet. But this is only inclusive in the interfaces that do not belong to a VRF. This down here, when we say network 10.0.0.0, even though this is a /16 and it overwrites this subnet here between 4 and 6, this network statement is only going to apply for IPv4 interfaces that belong to the VRF R2. So if we were to add, this interface for Ethernet 02 into that VRF, as a separate, maybe a duplicate link to get to R2, that would also apply to this VRF and this context. We could add another one if we wanted to, if we created another VRF. All right, so let's actually just play around with that. We'll say IP VRF, we'll call this test, and I'll say route distinguisher, we'll just say 1:1, and we'll say interface E02, do show run interface E02, and we'll say IP VRF forwarding. What do we call this guy? Test, right? I think. Let's say do show VRF. So there we have it. So this is the test VRF that we created. So we'll say router RIP and spell right, router RIP, address family IPv4, and we'll say VRF, and I'm going to go ahead and say test, and then I'm going to say version 2, no auto, and say network 10.0.0.0, and let's control C out of here and just bring up the whole config. Typos galore tonight. Maybe I should have watched the debate. Okay, so now here if we look at RIP, we have essentially two different VRFs configured underneath the same routing process inside of RIP. Of course, this guy's not going to do anything, but that's okay, right? Because we're connected on this interface, not the end of the world. Just something you may want to do when you're creating the RIP process. If you're going to have a global process like this, you may want to play around with your passive interfaces and just see what happens and make sure that you're not going to send out global routing packets out of other interfaces, and just make sure that you're configuring it as per the requirements that that they're asking you to. So anyway, let's go to router 2 here. Let's wake him up. And let me say show IP protocols. I'm not sure if we have RIP already configured. Doesn't look like we do. We only have OSPF for the DMVPN, so ignore this. So let's get RIP running. So I'm going to say router RIP no auto. Oops, sorry, version 2 no auto. We'll say passive interface default no passive E01. No passive E01, redistribute connected, network 10.2.4, well, it doesn't really matter, right? Do show run, section RIP. Okay, so we're going to redistribute all of our connected interfaces. We're running version 2. We defaulted all of our interfaces except for the one going to router 4, and we've gone ahead and said, hey, just enable RIP on everything. Let's actually go over to router 4, and let's say show IP route RIP. And you can see that I only have the stuff from router 6. Reason is because I dumped all of these routes into a separate VRF. So let's check that out. Let's say show IP route, and I'm going to say VRF R2, and we'll say RIP. And now you can see that router 4 is now accepting all of these routes coming in from router 2, but it's doing it under a separate routing table. And it lets us know that, hey, this routing table is R2, but it belongs to that particular VRF. So I can say ping VRF and say R2, and I can say 192.168.2.1, and I can ping successfully. Now, what about the interfaces on R4? What if I want to, kind of separate out who gets what? Well, what I can do is I can go into my RIP process. So let me say config T and say router RIP and say redistribute connected, right? So now at this point, all of these interfaces are going to go into my global routing process. So if I say show IP route RIP, you can see that on router 6, I have only the stuff that's in the global routing table to router 4. But what if I want maybe this one interface to go towards router 2 instead? Well, I can do that by adding this loopback 1 into that VRF. So I can say loopback 1. Oh dear. Interface L1, and I can say do show run interface L1 and say IP VRF forwarding, and we'll go ahead and put this guy into R2, and then I'll go ahead and reapply this subnet. And if I go over to router 2, let's say do show IP route RIP. Oh, I forgot to say redistribute connected under the, let's say do show run section RIP. And let's go into our RIP process, and we'll go under our VRF and we'll say redistribute connected. And in theory now over on 2, we see that one interface that we went and put into that VRF. You follow what I'm saying? So now at this point, R4 is going to advertise that one interface. If I say do show VRF, it's going to advertise this loopback one interface into the VRF and over to router 2. So be careful there. Don't get confused. You know, if you're under the VRF and you're typing redistribute connected, do show section RIP. If you're entering redistribute connected under a VRF and you're not seeing anything, it could be because you have not added those networks on that local router, those interfaces, into that VRF. So be careful there. Now I want to test one last thing. I mentioned something. Let's say do show run section RIP. And let's try to at least have minimal typos going forward. I am just a disaster tonight. So here in this section, we've gone ahead and we've said, okay, passive interface Ethernet 02, right? What if under our global RIP process, what if we passive interfaced Ethernet 01? What would happen if we did that under the global process? Let's say do debug. I keep missing keys here. Debug IP RIP. And let's actually watch our updates. So we sent an update here. It says sending version 2 update out 224.0.0.9 out this particular interface. And we received an update from router 6, but did we send one over to router 2? Could be. Let's wait. Let's see what happens. Let's debug router 2 as well. Let's say do debug IP RIP. Go back to 4. We see that we did receive something. So we received an update here. So we received an update from 6, we received an update from 2, and it looks like we sent one over to router 6, we received one from router 6, router 2 hasn't gotten anything. So let's say do show run section RIP, and let's take a look at RIP over here. So we sent an update over to router 4. So at this point, my point is and when I was trying to say before, and the reason why I did this was because I realized I may have said it a little bit backwards or confusing for you guys, is you have to be careful in how you set up your passive interface. Because if you passive interface out in the global process and interface, even though it's a member of a VRF, you may inadvertently stop yourself from sending out updates, even though that interface is in a VRF. Right, so be careful there, and that's really what I was trying to say before, and I figured let me show you and make it a little bit more clear, because you can see by the debug on router 2, we've now stopped receiving any updates from router 4 because we've passive interfaced out that interface in the global process. So let's remove that. We'll say no passive interface E01, and then let's see if we actually receive an update. So let's go to router 2, sending. Let's see if we can kick this guy back in the head here. Sending an update over to router 2. So here we go. Here was the sending of that update once we no passived the interface, and if we go to router 2, now we're receiving it. So be very careful there. Again, that's what I was trying to say with, be careful. You may want to passive interface out some things and whatnot, but be careful what you passive interface. Okay? So this is how we play around with RIP in VRFs. I will see you guys in the next video. I am going to go to bed. Good night, guys.